Calimera, folks. It's nice to be here. My name is Federico. I work at Contino as VP of Engineering. Been with Contino for the past 5 years. We're a DevOps and cloud consulting firm. This talk comes from our experience helping large enterprises move into cloud and building architectures in cloud with Kubernetes. There are two things of logistics, if you want, that I want to share with you before we start the session. Number one, this will be an intermediate plus level talk, so I will assume familiarity with most of Kubernetes and cloud and all sorts of things. But if I skip on something, feel free to reach out to me at the end of the session. And second point, more interesting for you, is that this is meant to be an interactive talk. So I have 5 questions. 5 questions for the audience in the slides. At some point it will pop up. I will need your help to go through these questions together. So I'll need some interactivity from you. I'll need people to shout some answers, ideally, right or wrong. The questions are very easy, but I'm gonna need your help here, all right? Perfect, so let's start the session together. First thing I wanna tell you is a bit of a super quick, brief history of Kubernetes and containers. What I want to draw your attention here is that Kubernetes has been in the ecosystem for a number of years now. This is not a new technology. It has been there for, at the very least, 15 years as we know it. Kubernetes. Cluster schedulers have been in the ecosystem for years and years. They did the 70s. Kube, containers, more recent. But still, this technology we're looking at this as if it was something really, really new, but it is not that new. It's been there for a while, and we should have some maturity in the ecosystem. As much as we're seeing this in JavaScript world, where we're seeing maturity in the frameworks ecosystem, we should see the same thing in Kubernetes, because now we have CSPs, cloud service providers, offering Kube. We have hybrid offerings with some on-premises, some in cloud. We have the Cloud Native Computing Foundation backing more than 100 projects with a variety of different components part of the ecosystem. And let me tell you something, Kubernetes is amazing. So even if we remove some things from my slide there, you can see that Kubernetes is now at its supremacy level because there are virtually no other cluster schedulers that have had the same level of adoptions. The competitors have effectively disappeared. And now, in our experience, when I work with enterprises and they come to me and they say, oh, we want to go to Kube, we want to go to cloud, the one big reason why everybody says, I want to use Kube is very simple and pretty straightforward. I want to use Kube because it will enable me to port my applications from one cloud provider to the other. I will avoid vendor lock-in. I will move from on-premises, my DC, into any CSP, and that will be very, very easy because Kubernetes enables that. If I package my app as a container and I deploy it in Kube, I can deploy it anywhere Kube runs. So today, we're going to see whether that holds true or not, if the big statement there is true or not. How we're doing it? We're playing a game. All of us here in this room today, are part of a migration team. We're working for a B2C startup company that has an application on the Play Store, and iOS Store, Apple Store. And we have to migrate this app from AWS to GCP. We're going to do it together. And we're running this. We are the migration team. We're going to make some choices during this work. Good news are that from AWS to GCP and the landing zone or the foundations on GCP have already been built. They are fine. We have GKE, GKE for Google Kubernetes Engine, up and running on GCP. We can stop the world in our migration, so I can turn off AWS and I can turn on GCP on the other side. We have a very modern tech stack. We'll see in a moment the architecture. And we don't worry about networking. We don't really worry about how we're going to do any clever traffic shifting or anything complex. Takeaway is this is an easy technical migration from one Kubernetes cluster on AWS to one Kubernetes cluster on GCP, and we can do whatever we want with it. We do have, however, a number of stakeholders that I want you to keep in mind, because when we're moving something from one place to the other, it's not only about our users that need to keep on being able to use in the app, but the security team needs to approve the new deployment in a corporation of any sorts. Our mobile developers need to be able to do their tests. Our backend developers need to be able to deploy their code. Our SRE team, if we have one, perhaps at scale, needs to be able to operationalize our application. Okay, perfect. So all of these concerns seen, let's take a look at the app together. So this is the app. As you can see in the architecture here on AWS, we have a mobile application uploading some images on one microservice number 1, deployed on EKS. This microservice does two things: takes the image and uploads the image to S3, super simple, and then stores some metadata information on a RDS database. There is some queues, super standard, SQS, SNS, whatever you want, their queuing system that we use for microservice 1 to tell microservice 2, hey, I have a message. Goes to microservice 2 says, thank you, I'm gonna pull the image from S3, do my modifications, and send an email to the user saying, I've added a watermark, I've added a filter to your image, I've changed something in the image. We're using Grafana and Prometheus to monitor the application. And we're using HashiCorp Vault to store our secrets. So we have this third-party email sender, think about SendGrid or MailChimp, and we have an API key for that there. So super simple. You can picture this a Golang, very advanced microservice, suite of 3 microservices, super small, none of them really doing anything special. There's a queue, there's a database, there's a bucket. Pretty straightforward. In GCP, what do we have? We have the same architecture. We have 1, 2, 3 microservices. On GKE, we have Cloud SQL, our database for Postgres database. We have cloud storage, S3 counterpart, and we have the external email sender. Pretty straightforward, as I said. 3 microservices, 1 database, 1 queue, 1 storage system. And we have a journey we have to follow. We have a migration journey from one place to the other. The big promise here is we have a turnkey migration. I want to be able to do nothing because they told me when I, quote, bought Kubernetes, they told me Kubernetes will enable you to port the application from one place to the other. So the big question for you now is, based on this YAML, this declarative YAML that shows what the application does, if I just change my CI/CD, my GitHub Actions, and I change the endpoint on GitHub Actions from EKS to GKE on GCP, will it work? Yes or no? Please shout answers. Yes or no? No. Why? Sorry? Okay. People saying because the service is not one-to-one to one cloud to the other. Fair enough. But specifically, why not? Go for it. Shout it. Okay, if I understood it right, the repository is different. Yes, so that is the problem. The problem is the image is stored on ECR on the Elastic Container Registry on AWS. Question, can a GKE instance pull images from a Docker registry hosted on AWS? Yes or no? Yes, but there are trade-offs. So I have 3 options. Option 1, I can host my container on Artifactory, commercial solution, or Harbor within the cluster, port them over from one place to the other, and I can more easily move the application. I can keep the containers on ECR and pull them from GKE. But if I do that, I need to use a shim. So I need to change the way in which GKE authenticates to pull the images, and which means that GKE managed nodes don't work anymore. I need to use self-managed nodes and tell the self-managed nodes, go to ECR that way. A bit painful. I lose automation, I increase my maintenance cost. Option 3, I move to Google Container Registry. Nice and easy in this case. Google Container Registry and AWS ECR are very much the same. Surface area, the same. I can write a super simple bash script or whatever language script that pulls all the images from ECR, pushes them to Google Container Registry. I update the YAML, and I'm fine. In this case, this Kubernetes dependency external to the cluster is easy to overcome, but it's a dependency. The only problem with the game is that our security team says, yeah, but that is a bit of a strange thing you're doing there. Why? Because security teams, I'm sure that most of you work in enterprises that have dedicated security teams, or you have somebody in your company that looks after security. Security says, are you following best practices or not? Because if you're following best practices, I really want you to do it. One of the most common best practices out there are the CIS benchmark or the NIST cybersecurity framework. Those benchmarks will tell you if you're deploying on EKS, follow this path. If you're deploying on GKE, you need to enable a feature called binary authorization on GKE. Binary authorization is a way to control supply chain security, so that you say, if you're deploying on GKE, you need to have a signed image. We weren't really signing our images on AWS because the Elastic Container Registry did not support that feature. So that's a problem, because it would mean that we not only now need to change the container registry, we have to change the pipeline, we have to sign the containers, everything. So there's more complexity there. What I want to draw your attention to is to say, from a technical standpoint, it was easy to move the containers from one place to the other, but security was a significant hurdle that needs to be factored in the migration control. But in this case, we're lucky. Our security team says, go ahead, push ahead, not a problem. We'll forget about that. So now, will it work now? Can I just redeploy the applications on GKE? Will they work? Yes or no? No. Perfect. Why? Very good point. On the queues, hold the thought for a second. We'll come back to it. In this example with this YAML, yeah, totally. So there's an API gateway problem, but we're going to ignore that for now. Looking at the YAML here. So we have that, sorry? Credentials. So we have a different database. That's a big thing. The big thing is we have a different database. So the endpoint is different. Pretty clear that if I deploy on GKE, can I use database stored on AWS? Yes, no? Well, maybe I can, maybe I cannot. So I'm going to redeploy on Cloud SQL. I can do a number of things. The good news is this is 2023, not 2019. Why is this a good thing? It's a good thing because Cloud SQL and RDS are very much overlapping, so I can move from one to the other. If I run Postgres on RDS, I can deploy Postgres on Cloud SQL and continue with it. There's no problem with the act in itself. It doesn't change our security posture. But one thing changes, which is, can I not do something better than that? The first thought that comes to mind is, I would have avoided all this pain if, rather than using RDS on AWS, a managed service, I would have used the Postgres operator and deployed my database inside the cluster. If I have the DB inside the cluster, it means that I don't need to worry about this dependency that I have there. The problem is is always the same, and is a trade-off that will take us throughout our journey here. If I deploy on the Postgres cluster, Postgres on my cluster, I have to maintain it. Now, companies are doing it. We can see as well that one of the most famous companies doing it is Zalando. Zalando has this open source project called Patroni, which is HA Postgres deployed in high availability mode in Kube. very well, works very well, is very stable. So I could potentially bring it in the cluster, okay? But what do I do when I do that? If I bring in something in the cluster, I reduce my vendor lock-in, yes, because the cloud provider, I'm not dependent on the cloud provider, but I do something else. So what do? I increase my total cost of ownership. Because now I have to maintain Postgres in my cluster, I have to do the upgrades, I have to do all the controls, I have to maintain everything around myself. So what I want you to think about here, which is a second takeaway, I hope, of the talk, is that yes, 100%, you can bring in things inside the cluster using Kubernetes features to reduce your dependency on a cloud provider, but you're making a business choice. You're not making a technical choice, okay? Your business choice is, I'm happy as a company to increase portability at the cost of maintenance. And I really want you to think about this. That is not a technical problem, okay? It's not a technical problem. It's a business problem. Okay, perfect. So we're there. We did our first changes. We changed the container registry. We changed our database. Finally, will this then work? And the good news is, yes, our microservices are all up and running, and our user tries to upload an image. The user tries to upload an image, ouch. The user gets HTTP 500, internal server error. Doesn't work. Why? That's a very good answer. Somebody said, Google Cloud Storage is not S3 compatible. Yes, let's look at that. Let's look into that. Let's do a bit of a deep dive. As you're saying, we were using S3 on AWS. Now, can I pull an image from AWS S3 from a GK instance? Answer is, yes, I can do it. But do I want to do it? As before, I'm left with three options. Option number one, I can use CNCF-backed projects, such as Rook or KubeFS. KubeFS being a distributed subsystem that is designed to support large-scale container platforms. It's a file system, storage file system, so you can import a dependency inside the cluster, as you were doing for Postgres. Option two, I can keep my data in S3, but I have two problems now. Number one, I still need to authenticate to AWS APIs, so I need to use my managed nodes on GKE. Option three, I can just move the storage to GCS, Google Container Storage. Google Container Storage that runs in very clever ways. Google Container Storage, for example, recognizes that S3 is the leader in the industry, and as a result, offers an S3-compatible API surface. So using S3, I can change the endpoint of the library that I'm using to point to GCS without changing anything else. So I can use AWS S3 SDK to put and pull documents, images, blobs from S3. Or I can leverage some of Kubernetes' less known features, something called Google Container Storage Interface. Container Storage Interface is a standard, is a feature of Kubernetes that became GA a few versions ago that enables a very clever thing, enables you to expose arbitrary blocks and file storage system to containerized workloads using third-party storage drivers. Very complex way of saying something very simple. Let's look at this together. So what we were doing before was that our HTTP microservice was making a API call to S3. What we can do with Container Storage Interface, I'm going to do something else. Rather than having an HTTP call, the container will mount a folder, and the container will write on this folder. Then behind the scenes, the driver will take the data on this folder and send it to S3. So now the container and the application, the microservice, only sees the local folder, doesn't see the storage dependency there. which is really great because if I change my storage dependency, I can just point to GCS, Google Container Storage. So I don't need to touch the application at all. What we're doing here, another common trend, another takeaway, is that to increase portability in cloud, what do? We shift from code dependencies to configuration dependencies. So we're moving to the configuration. This is a very cool feature that Kubernetes has that increases the ability for you to move files from one cloud provider to the other. But as in most things, there's no free meals. So as in most things, this does work. The drivers are available out there, but don't forget that S3 is object storage, and your folder is typically block storage. So there are problems. The what is called the POSIX compliance limited is not complete. The application in itself is not cannot do all the things that maybe you want to do. For example, the drivers today don't support file ownership, so you cannot change the ownership of a file, for example, which is something you may or may not want. You need dependencies inside the cluster. But the feature is available and is very, very powerful. There are also similar projects, DataShim being the most advanced one, that allow you to do something very similar at scale. So this is another way of increasing cloud portability using CNCF-backed projects. So in our case, what are we doing? We're saying happy times, moving from S3 to GCP to Google Container Storage, super easy. Also because the way in which my container and my pods authenticate to the cloud provider is now exactly the same. So they use service account both on AWS and GCP. One dependency, though, is the one you see in this image here. So in this image here, dependency is I still need to change my source code. I still need to change my source code. I need to change the library from S3, bottom Python, AWS, Go SDK, whatever that is, into the Google libraries. That's a code change that I need to do. Now, picture this. This may be straightforward, but picture this. If I have one application, I'm super easy to do that. But if I have 50 microservices, if I am a company like Monzo or Netflix and I have 1,500 microservices, if I have 2,000 microservices, how am I supposed to do that game? That is where we can start seeing interesting patterns coming up. So another interesting pattern is the anti-corruption layer. Way for you to say, I'm going to create a facade, I'm going to create something that stays between my container and S3, such as if I have to move across multiple, if I have to move multiple containers, if I have to move multiple microservices from one cloud provider to the other, they can all change because they all talk with, they can all stay the same because they talk with this anti-corruption layer, and then I only change the implementation behind the scenes. It's a facade, is an adapter layer. The thing with that, though, is that you start to introduce complexity, you start to introduce dependencies as well. But it's a super clever thing, because as we said, if I have 2 microservices, I start changing one application, or I start changing one layer only, rather than changing multiple layers. Okay, perfect. So finally, we deployed our app. We're here. We now have this YAML. We're saying, okay, everything was fine. Somebody before said, what about the queues? Well, question. I have my microservice number 1 uploading a message to the queue. The microservice knows where the queue is because of this configuration here. Can I just change the endpoint from sns.eus to pubsub.google APIs? Can I just change the endpoint from SNS to pubsub? Most people correctly said no. But I'm going to ask you why. Why not? The API is different, but why? Because, why am I asking this? Because we as a company, we're making a very basic use of a queuing pattern that has been in the industry for 30 years. Why are the APIs different? I don't know. I mean, I'm asking, right? So why the APIs are different in this case? we will do a bit of a deep dive on why the APIs are different. But think about this: we're making a very very cursory usage of the queuing system. The pattern has been standard for 30 years. We don't use any advanced features. We don't use DL queues. We don't use any sharding, partitioning. There's nothing like this. We're a super simple use case. Still, for a super simple use case, I need to change a lot of things. Let's see the options, and we'll get more to it. So the options are, as before, 3 options. Option number 1, to increase portability, bring in a CNCF tool, Kafka-like, inside your cluster. There's Nets, there's Kafka, deploy Kafka inside the cluster, use Kafka for your messages. You don't depend on the cloud provider. You increase portability. Option number 2, keep messaging in AWS. Option number 3, move messaging to GCP. Now, I could do all 3, but clearly for consistency, we want to turn off AWS. We're going to go for changing to GCP. Okay. Actually, before I do that, I wanted to stress one point. So, if I use GCP, if I have data, if I use GCP and I have data on AWS, then I need to pay egress cost as well. In this case, it's just a message. That's probably negligible egress cost, but it's something to keep in mind. So I move to GCP. Now I have a problem. Now I have a problem because I need to change my application. I need to change the API surface is different. I need to change library. So I need to import a different library. And whether before, in most companies I work for, the applications are typically very well structured, and the file storage, the storage dependency is stored as a separate component of the application. The queue is more tight with the rest of the core application logic. So if you don't have a clear boundaries, typically this starts being a more painful activity than before. Is there anything else that I can do to make it better? Because as we said, we are making a cursory usage of a pattern that has been in the industry for 30 years, if not more. Okay, CNCF-backed project, Dapr. Dapr is the answer to this. Dapr is a CNCF-backed project that was started by Microsoft in 2019. Dapr, this is the definition from the website, is an event-driven runtime that enables you to do a number of things that are independent of the place where you're hosted. For example, gonna look at things very, very simply. So Dapr operates as a sidecar container, so you're deploying it alongside the other containers in your pod, very similarly to how Istio is deployed as well. And you can call Dapr over HTTP on a local host call. The game is the following. Whether before Microservice 1 was talking to Microservice 2 via SNS, now Microservice 1 talks with Dapr. And Dapr then talks with SNS. The application doesn't know whatever the Dapr is using is leveraging, and so if we change it behind the scenes, the application doesn't need to worry about that. This is very powerful, enables significant portability, because now to migrate things, what do I do? I just need to touch nothing. I just need to tell Dapr, stop using SNS and start using PubSub on GCP. So this is once again the pattern we saw before. We're shifting from code dependencies to configuration dependencies. So the configuration takes charge of worry about that, which is great because it enables us to be much, much faster at doing our things. Dapr is very, very powerful as well. So you can see here that we just need to switch the YAML, and then we can either import Dapr SDK, or as we're seeing in this example here, so I just import the available SDK, or I can just make the HTTP call myself directly, talking with the container sitting next to me. So that enables significant portability. We can see the Dapr as a very wide API surface. Not only enables us to move from one queue to the other queuing system, but also enables secrets management, enables configuration, distributed locking, enables the service discovery, state management, a number of different things that are enabled by Dapr, which is really, really powerful when it comes down to migrating your application from one place to the other, even if it is still not perfect. Dapr today is not perfect. for two reasons. One reason, the way in which Dapr works. So if I'm moving my logic to deconfiguration, then the logic is static during the runtime of the code. Convoluted way of saying. If your application was doing something clever, so connecting to one queue at the beginning of a transaction and then connecting to a different queue during the transaction, obviously, if Dapr is managing this queuing connection, you lose that ability because it's outside of the realm of the application now. But you gain something. You gain portability in doing this game. The second problem with Dapr, which is more interesting, I think, and something to think about when you're adopting a service like this to move your application, is to say, okay, how do I do secrets management in this case? As we said before, secrets management on AWS was managed by Vault. When we're moving to GCP, we want to move to Secrets Manager. Now, we know that Dapr is our solution. Dapr is our solution because we have HashiCorp Vault fronted by Dapr. The application doesn't even know that HashiCorp Vault is there. And also, I should mention, Dapr works on premises as well. So if you have the application running on-prem, you can do the same thing. The thing is, though, I'm moving Secrets Manager, which is really, really great, except for one thing. This is a subtle thing, but I want to draw your attention to that mapping there. That mapping there is a specific thing that says, this is my secret, and my secret is a key, multiple values. One key, two values in the secret. Multi-key value pairs per secret, effectively. This is a feature that exists only on HashiCorp Vault, but does not exist on Secrets Manager. Now, what Dapr does in a case like this, where you have a feature that exists on one side, but doesn't exist on the other side. In a similar way, PubSub has a number of resum features and replay features that don't exist on SQS. And so, what does Dapr do in this case? Well, Dapr has to do one thing, the one thing that Dapr can do, which is revolving to the minimum common denominator, revolving to the most common things across the different options that I have available. So for our use case, Dapr was perfect because we were making a super simple use of a standard pattern, and we did not care about advanced features. But if you were to use more advanced features that are specific to the queuing system, a platform like this can become a problem, even if it's a very, very powerful tool and system. Perfect. So finally, our migration journey has gone through so much, and will it work? The application is up, everything is up, everybody's happy, but why is our SRE team screaming? The application is up, everything is running. Why are they screaming like crazy people? Any ideas? Maybe a hint. Here is a hint. Any ideas why the SRE team is screaming? So we have Terraform in a trash can. There's Terraform in a trash can. What happened here? We lost the state in Terraform, exactly, and also because, frankly, we are a migration team. We are Kubernetes people. We don't care about Terraform, okay? So we just use the console, and our SRE team says, you're a bunch of fools. You gotta use infrastructure as code. But we don't know Terraform. We don't want to depend on Terraform. What can we do? There's another CNCF project that can really help in this case. It's called Crossplane. Crossplane is another CNCF project that uses Kubernetes controllers and declarative YAML configuration to deploy resources external to the cluster. For example, you can ask, I want a Postgres database outside the cluster. Give it to me. I don't care what the database is about, which is great for portability. Let's see how it works together with a simple example. We can define as a Kubernetes YAML a resource, a S3 bucket in this case, but I can have a RDS database, anything like this. I deploy it on Kubernetes, And then Crossplane behind the scenes goes and creates my resource. So treats the YAML as a declarative command. Deploys this resource, which is great because it enables portability. In a similar way, you can see these composite resources that we have here. So our SRE team can say, don't ask for a RDS database, ask for a Postgres instance. And then the SRE team behind the scenes, the platform team that you have behind the scenes, can say, whenever they ask for a Postgres instance, give them RDS if you're on AWS, give them Cloud SQL if you're on GCP. So once again, another clever way to enable portability at scale. So our migration journey is almost completed, and we see that now the answer to the question, will it work with all the microservices up, is yes. Now the application is deployed in cloud, And the good thing that we did at the beginning was using clever monitoring services rather than using a service that would have locked us in a bit more, I think, like CloudWatch or GCP Monitor as well. We've decided to use Prometheus and Grafana, which are great services. They are backed by the CNCF as well. They are managed on AWS, but enable a level of portability that choosing something else would have not have enabled us. And now the final architecture you can see here, where we now have Dapr deployed that enables us to move from one place to the other. We have the application fully running on GCP and monitored in the right way. So takeaways. I often see companies saying that they're adopting Kubernetes because it enables them to reduce vendor lock-in and move from one place to the other. The reality is that Kubernetes as a platform is not feature complete. So you have all these dependencies of the ecosystem, okay? Yes, one container can easily move from one place to the other, but an application, much more complex. And as a result, we have a sprawl of components of a complex ecosystem that enable us to move a bit more, but there's still hard work. Cloud portability is hard work. This is what I wanted to tell you. And in fact, 5 key takeaways in the last minute of our session are, number 1, we've all seen that the ecosystem plays a major role in this, for sure. We've seen that the current trend in the industry to enable application portability is to move from code dependencies into configuration and using the services in the configuration, either within Kube or outside of Kube, to enable migration using open source tools for help. And we realized as well that the trade-off of the scale was shown you before, portability comes with a cost. It's a great thing, but you're making a business decision when you're making it. So thank you for coming to my talks. I'm available here if there's any questions.